Assembly of soil monitoring system. Components required: NodeMCU, voltage regulator, soil monitor sensor, battery snapper, breadboard, USB port. So this is the soil moisture sensor, this is the probe, and this is the IC module. So this probe we need to insert it in the soil to check how much the moisture level, and this we will connect it to the NodeMCU. First of all, we need to connect this probe to the IC module by using the wires. Just connect the two terminals to the two ports. Now there are four terminals here: analog pin, digital pin, ground and VCC. We place the IC module on the breadboard in this way and take some jumper wires. Connect the analog pin to the A0 pin of the NodeMCU. Then the VCC pin to 3V pin of the NodeMCU. Connect the ground terminal to the ground pin of the NodeMCU. Now, if we need to power the NodeMCU using battery, then we will use the voltage regulator. Place the voltage regulator on the breadboard. Connect the positive of the battery snapper to the VIN pin and negative to the ground pin. Then connect the Vout pin to the VIN pin of the NodeMCU. And the ground pin to the ground pin of the NodeMCU. Now if we connect the battery, we can power our NodeMCU and the entire circuit. Or else we can use the USB cable. Then we don't have to connect the VIN and the ground pin. Use the USB cable, connect it to the one port of the NodeMCU and other port to the PC.
Hello everyone. After the hardware connection of the soil monitoring sensor, now we will do the Blynk configuration. So first of all, we will open the Blynk website. So here in the dashboard, first we will click on the developer zone, and here under my template we will click on new template. Then we will select the we will give the name as soil moisture. Select the hardware as ESP8266, connection type is Wi-Fi, and then click on done. Once it is done, now we will create the data stream for the template. So click on data stream, click on new data stream, select virtual pin, and then here give the name as soil moisture. Select virtual pin V1, give the maximum value as 100, and then click on create. The data stream for the soil moisture is created. Now we will go to the web dashboard. From the widget box, we will select the gauge and drag it to the dashboard. Then click on the setting option. Click on choose data stream. Select the data stream soil moisture and then click on save. So our widget is added. Now we will go to the events and notification, and here we will click on create event. Then click on custom. Enter the name as soil moisture. Give the description, suppose as moisture is less. Give the type as warning. Note under notification, click on enable notification. Push notification to select device owner. Enable the notification management and deliver push notification as alerts. Go to the settings. Here event will be sent to user only once per. Here you give as 1 minute. and enable device page and home screen show in notification and event section. Under here you enable the device page and the home screen and then click on create. Your event is created. Now we will require this event code during our coding. So our template is created. Now click on save. Go to developer zone. You will be able to see the template. After that we will add device. So go to devices. Click on new device. Select from template. Then under choose template select soil moisture and then click on create. Your device ID, name and token is created. Click copy this part as you will require this during the coding. So when now you will click on the device, you will be able to see the soil moisture device here. And when the NodeMCU will be connected, it will show on the status as online here. So this is all about the Blynk web configuration. Now we will do the Blynk mobile configuration.
Blynk mobile configurations for soil moisture monitoring. Here first open the Blynk IoT app. As we can see the soil template that we have created, click on the template. Then click on the setting option, click on the plus option and select the gauge. Now select the gauge and select the data stream as V1. In the design part you can change the color. And then go back. As you can see the gauge is being displayed on the template.
So after the web page and mobile configuration of the Blynk, now we will do the coding for the soil moisture. Now this is the coding. Here the first two lines we have given is the Blynk template ID and the template name. These are written so that our ESP8266 can communicate with the right template. Then here we have included the ESP8266 and the Blynk library. The ESP8266 Wi-Fi library allows our NodeMCU to connect to the Wi-Fi, and the Blynk library allows the NodeMCU to connect with the Blynk app. Then here we have created a variable M sensor to store the value from the analog pin A0. Since we have connected our moisture sensor to the analog pin A0, then we have created one more variable MS value which will store the raw moisture sensor value. And then we have set the soil moisture threshold, that is 20, and M% to show the moisture value in percentage. Here we have given the token from the Blynk device. This authentication token is used to connect our hardware, that is the NodeMCU, with the Blynk app. And then we have given our Wi-Fi and Wi-Fi password. Inside the void setup, we have begin the serial monitor at the baud rate of 9600, and then we have given Blynk.begin, which will connect our ESP8266 to the Wi-Fi and the Blynk app. Inside the void loop, we have given Blynk.run to keep the Blynk connection with the NodeMCU alive. Then MS value is equal to analog read M sensor. This will reach the value from 0 to 1023 from the sensor pin. Lower the value, lesser the value, more wet is the soil, more the value, less the soil is drier. Then here we have given M% equal to map MS value 0, 1023, 100 to 0. This converts the raw value to a percentage, so it is easier to understand. Then we have given serial print ln M% to display the percentage in the serial monitor, and we have written blynk.virtual write v1 M% to send the data to the Blynk app on the virtual pin v1. And if loop to check whether the sensor value is less than the threshold value or not. If it is greater than the threshold value, then it will send the notification to the user that the moisture has decreased. And we have given a delay so that the moisture is stable, so that the data value that is sent is stable. After the coding is done, we will go to tools. Under the board, under the ESP8266, we will select NodeMCU 0.9 or NodeMCU 1.0, and then from port we will select the required COM port and then click on upload. The code will be uploaded to the NodeMCU.
Output for soil monitoring with Blynk App. So first we will see that we have connected our probe in the soil, and since the soil is very dry, we can see the output on the screen as 1, and also it has sent a notification to our phone that the soil moisture has decreased. Now as soon as I will give water on the soil, our moisture level will increase. As I am applying water, you can see the moisture level has increased. Similarly, we can see the value on our mobile app also. Thank you.